Dear students, today the topic of discussion is kinematic chain. Before proceeding to this topic, I will request to please go through the previous lectures because as we move from lecture to lecture, we have to recall the concepts that delivered in the previous lectures. So it will be very much beneficial for you guys if you know the concepts that delivered in the previous lecture. um, till right now you haven't gone to the previous lecture, then I will request you please go through the previous lectures and then move to this lecture. So let's start the um, discussion on kinematic chain. As you can see, there is a combination of links and joints. There are 4 links: 1, 2, 3, 4, and these 4 links are joined together by the 1 joint, 2 joint, 3 joint and 4 joint. And at this joint, these 2 links, 1 and 2, 1 and 2, these 2 links are joined together by this point. So that's why 1 and 2 link are called the pair link. This pair link is joined by this pinpoint. Similarly, this link and this link is paired due to the joining at this point. Similarly, this link and this link, they are joined together by a pin joint at here. Similarly, this joint is coupled to the first joint at this point. So how many pairs you can have here? 1 pair, the pair of this and this link. The second pair between this and this link. Third pair between this and this link, and the fourth pair between this and this link. So what will happen if any of the link is moved? Any of the link. So there are 4 links, 1, 2, 3, 4, and there are 4 pairs, 1 pair, 2 pair, 3 pair, 4 pair, and there are 4 joints, 1, 2, 3, 4. So if there is a motion in any of the link, let's see if there is a motion in this link. If this link moves in any of the direction, then the other links will move too, because the other links are paired by the joints, and these joints will have will constrain the other links. For example, if there is a motion in this link, then this link, and that link will move because they are paired by this joint, this joint, this joint and this joint. So if there is a motion in any of the link, then the motion will be transferred or transmitted to the other links as well. So an assembly of links in which the relative motion between the links is possible and the motion is constrained. Also, there is a condition that motion will be transferred from the first to the last link, or vice versa. Vice versa means the motion can also be transferred from the last link to the first link. So what is happening, that whenever as I mentioned earlier, that whenever there is a movement in the link, any of the link, then what is happening, the motion will transmitted or transferred to the other links as well, and the motion will be constrained motion. So in the kinematic chain, what will happen? The constrained motion. Uh, if you recall your memory in the previous lecture, what we have said about the constrained motion, the motion will be in a single direction. Either motion will be a translatory motion in one direction, or motion will have uh, a rotation in any of the direction, clockwise or anti-clockwise. So let's move to the next slides so that you may know what this kinematic chain is and how we can identify the combination of links and joint as a kinematic chain, or something else. To predict the combination of links and joints is to be called kinematic chain or not, we have two equations. Equation number 1, equation number 2. Equation number 1 is L equal to 2p minus 4. L is our right hand side in the blue color, 2p minus 4 is our right hand side in the red color. Equation number 2 is J equal to 3 by 2 into L minus 2, where J is in blue color or left hand side, 3 by 2 into L minus 2 is our right hand side and in the red color. What these L, P and J represents: L is number of links, P is number of kinematic pair, and J is number of joints. Oh yeah, so to know that any combination of links and joints, they are to be called kinematic pair or not, we have two equations, 1 and 2. So there we will discuss the condition number 1 when our left hand side in both equation become equal to right hand side. If this condition happens, means left hand side is equal to right hand side in both of the equations, then the combination of links and joints will be called kinematic chain, and the motion will be constrained motion. I will repeat again. The condition number 1 is if left hand side and right hand side of both equations, left hand side, right hand side of equation number 1, left hand side, right hand side of equation number 2, if left hand side of equation number 1 is equal to right hand side of equation number 1, or left hand side of equation number 2 is equal to right hand side of equation number 2, in any of the equation, if the left hand side and right hand side are equal, then the combination of links and joints will be called kinematic chain and the motion will be constrained motion. Let's see the example and then you will be crystal clear what I mean to say. So here we have 4 links, 1, 2, 3, 4. These 4 links are joined by 4 pin joints, 1, 2, 3, 4 pin joints, and there are 4 kinematic pairs. Where are the kinematic pairs? Link 1 and 2. This is the 1 pair. Link 2 and 3, this is the second pair, they are joined by the pin joint. Link 3 and 4, 3 and 4, this is the another pair, it's joined by this pin, and the last one, number 4, is joined by the link number 1 by the help of this joint. So there are 4 pairs, 1 pair, 2 pair, 3 pair, 4 pair. So let's see the equation number 1. L is equal to 2p minus 4. L, the number of links are 4, number of kinematic pairs are 4. So put these values in the equation, we will get L the 4, 2 into 4 minus 4, and the end result will be 4 equal to 4. means left hand side is equal to right hand side. Therefore this type of combination of links and joint will be called kinematic chain, and the motion will be constrained motion, means if any of the links, any of this link or this link or this link or this link, if any of the link moves, for example if this link moves, then the other 1 2 3 these links will move too. I will repeat again, if you put a force on this link and this link moves, for example this link move in a clockwise direction, in this direction, then this link will also move, this link will also move, and this link will also move. So there will be rotation. If there is a rotation in this link, the other links will also rotate. So, and the rotation will be in the there will be only rotation motion. So there will be a constrained motion. There will be no translatory motion, only rotation motion. So let's see what happened to equation number 2. Can we get the similar results as we have in equation number 1? Yeah. So what is happening in equation number 2? We have a formula J is equal to 3 by 2 multiplied by L minus 2. So we have 4 links, 4 joints, 4 link 1 2 3 4, 4 joints, 1 2 3 and 4. So put the values of links and joints in the formula. What we'll get, left hand side is equal to 4, then 3 by 2 multiplied by 4 minus 2. If we simplify the calculation, then what we'll get, 4 equal to 4. Therefore if left hand side is equal to right hand side, then the combination of links and joint will be called kinematic chain, and the motion will be constrained motion, because there will be a the motion will be in a single direction. If the motion is in single direction, then the motion is called constrained motion. Let's discuss the second condition. The second condition says, if the left hand side is more than the right hand side of any of the equation, either equation number 1 or equation number 2, if in equation number 1 left hand side is more than the right hand side, or in equation number 2 the left hand side is more than right hand side, if left hand side is more than right hand side in any of the equations, then the combination of links and joints will have no relative motion, and the mechanism is not a kinematic chain. So this type of links and joints combination is also called locked chain. I will repeat it again. If left hand side is more than the right hand side in any of the equation, either equation number 1 or equation number 2, if left hand side is more than right hand side, what will happen, the combination of links and joint will have no motion at all. If you apply the force, then there will be no motion at all in the mechanism, and so this type of mechanism or combination of links and joint will not be called kinematic chain, will not be called kinematic chain. Rather, this type of combination of links and joint are referred as locked chain. I will repeat, if left hand side of the equation is more than the right hand side, left hand side is more than the right hand side, left hand side is more than right hand side in any of the equation, either 1 or 2, what will happen, there will be no motion between the links and joints, and this will not be called kinematic chain. Rather, this type of combination is called locked chain. Locked chain. To clear the concept of condition number 2, let's see the example. As you can see, we have a combination of links and joints where 3 links, link number 1, link number 2, link number 3, they are joined by 3 joints, 1, 2 and 3 joints. So 3 joints, 3 links, and also there are 3 kinematic pair. How? The first one is link 1 and 2. These 2 links are paired due to this joint. So there is a 1 pair between link 1 and link 2. So this is a 1 pair. Link 2 and link 3, they are paired by this joint. So this is a second pair between 2 and 3, and the pair between 3 and 1, they are linked. The link 3 and link 1, they are joined by this pin joint. So this is also making a pair. So 1 pair, 2 pair and third pair. So 3 links, 1, 2, 3, 3 joints, 1, 2, 3, 3 pairs, 1, 2, 3. Let's put the values in equation number 1. Equation 1 has L is equal to 2p minus 4. L is the left hand side, 2p minus 4 is the right hand side. Let's put the value of L, 3, p is equal to 3, the kinematic pair is equal to 3, link is equal to 3. Let's put the values in the equation number 1. What we'll get? The end result, 3 is more than 2, or left hand side is more than right hand side. If left hand side is more than right hand side, this means there is no relative motion between the links, and the combination of links and joints will be called locked chain, and this combination of links and joint will not be called kinematic pair, the kinematic chain. So this is not a kinematic chain cross. So this is not a kinematic chain, rather this is a locked chain. So there is no motion at all. If you apply force on any of the link from any direction, none of the link will move. If none of the link will move, so there will be no motion between the links. So there is no relative motion, and if there is no relative motion, this combination of links and joint is not a kinematic chain, rather this is a locked chain. Let's confirm this left hand side is more than right hand side. As we can see, equation number 1, is the similar thing is applicable in equation number 2 as well? Let's see. Yeah, as we know, the equation number 2, j is equal to 3 by 2 multiplied by L minus 2. Let's put the values. L is equal to 3, the links, number of links are 3, number of joints are 3. Let's put this value in equation 2. What we'll get at the end, 3 is more than 2.5. The left hand side is more than right hand side. So both the equations, equation 1 and 2, they say the same thing, that left hand side is more than right hand side. This means there is no relative motion between any of the link. 1, 2, 3, no motion. Whatever you do, they will not move. So let's see the condition number 3. What condition number 3 says? If the left hand side of the equation is less than the right hand side. So as you can see, equation number 1, L is equal to 2p minus 4. L is the left hand side, 2p minus 4, the right one is the right hand side. If in this equation L is less than 2p minus 4, or the left hand side is less than the right hand side. Similarly, in equation number 2, if j is less than 3 by 2 into L minus 2, or left hand side is less than the right hand side, if this happens, then the combination of links and joints will be called kinematic chain. But what is happening? The motion will be unconstrained motion. So there will be more than one form of motion here. So in case of constrained motion, if you recall the concept, in case of constrained motion, there will be the motion will be in single direction, where in case of unconstrained motion, motion can may have in multiple direction. So you have no control over the motion. In case of constrained, literally means you have control over the motion. Unconstrained means you have no control over the motion. In case of constrained motion, I will repeat it again, the motion will be in single direction. In case of unconstrained motion, the motion will be in more than one direction. Let's see the examples. So here the example has a rather a complex combination of links and joints. Let's count how many links, joints and kinematic pair are. So let's start from here. The link number 1, the link number 2, the link number 3, the link number 4, the link number 5, the link number 6. Also let's count the number of joint number 1, joint number 2, joint number 3, joint number 4, joint number 5 and joint number 6. 6 joints, 6 links. Let's count the number of kinematic pair. So first pair is between link 1 and link 2, so this is a 1 pair. Second pair is between link 2 and link 3, second pair. Third pair is between 3 and 4. Fourth pair is between 4 and 5. Fifth pair is between link 5 and 6, and the last pair is between, or sixth pair is between link 6 and link number 1. So 6 pairs. So I will repeat again, number of links are L is equal to 6, number of kinematic pairs are P is equal to 6, and also J, the number of joints are 6. So let's see, put this value in equation 1 and 2. In this case, let's first put the equation, let's see the equation number 1 and put the value of links, number of links and number of kinematic pairs 6 in the equation. What you will get at the end, 6, the left hand side is less than the right hand side 8. This means left hand side is less than right hand side. This means the motion will be unconstrained motion. The motion will be more than a one directional motion. Can we get the similar result from the equation number 2? Let's see. As you can see, the equation number 2 is J is equal to 3 by 2 multiplied by L minus 2. J is the left hand side. In the blue color, 3 by 2 into L minus 2 is the right hand side. We already know the number of links, joints and kinematic pair. Here we need the number of joints 6, number of links 6. Put this value in equation number 2. What we'll get at the end, 6, the left hand side is less than the right hand side of 7. Left hand side is less than the right hand side. Similar results as equation number 2. Equation number 2 has a similar results as equation number 1. Although the numbers are different, but the final conclusive results are same. Conclusive results are what? The left hand side is less than right hand side. So this type of combination of links and joints will have a unconstrained motion. Unconstrained motion, more than one directional motion. So that's all from the today's lecture. If you have any questions or queries, then please let me know. We can repeat the concepts anytime if you want, if you wish, but you have I will request again, please go through the previous lectures as well and recall the concepts, because as we move further in the lecture series of mechanics of machine, we have to recall the previous concepts. So you need the previous concepts all the time, so it's better to make or recall your memory time to time, And if you have any problem or difficulties, then please discuss me either on the WhatsApp or the YouTube channel or via Google Classroom. So see you again in the next lecture. Bye bye.